How to factor binomials. Example C. Factor the polynomial completely. We have x to the sixth power minus y to the sixth power. As always, factor out the GCF, if there is any. From our two terms here, it doesn't look like there is a GCF, so we're going to move on. Let's see whether or not we have a difference of squares or a difference of cubes. I'm not going to say a sum of cubes this time, because as we can see, this is only a difference. So remember, in a difference of squares, we would be able to rewrite the expression as something squared minus something else squared, a squared minus b squared. And if we can, then it will be factored to a plus b times a minus b. So let's take a look at what we have. X to the sixth power minus y to the sixth power. Could this be rewritten as something to the second power minus some other expression to the second power? You might want to recall that in the properties of exponents, if I have a power to a power, let's say a to the r to the s power, I can multiply those powers. So for example, x to the third to the fourth power, that would be x to the 12th power. Well, what we have is x to the sixth power. And what we want to consider is if this can be rewritten as something squared. Well, one way to think about that is to ask the question, can 6 be divided by 2? And it can. 6 divided by 2 is 3. So x to the third power to the second power equals x to the 6. So we could fill in here x to the third, since 3 times 2 is 6. And in the same way, this would be y to the third, since 3 times 2 is 6. This means that our a is x to the third power, and our b, y to the third power. So moving forward, we can rewrite our polynomial as x to the third power plus y to the third power times x to the third power minus y to the third power, using the difference of squares formula. Now remember, we want to factor this completely. Let's check out the two binomials that we end up with. It looks like the first binomial is a sum of cubes, and the second binomial is a difference of cubes. Remember, the sum of cubes lets us rewrite a binomial in this way. If we have a to the third plus b to the third, this would equal a plus b times a squared minus a times b plus b squared. In the difference of cubes, a to the third minus b to the third, this will factor to a minus b times a squared plus ab plus b squared. It looks here, in both of these binomials, a is x and b is y. So let's go ahead and substitute in the values into the sum of cubes and the difference of cubes formulas. We end up with x plus y times x squared minus xy plus y squared. That is the factored form of the first binomial. Then the factored form of the second binomial will be x minus y times x squared plus xy minus y squared. We are done.